if you want to look at what the shortcut we're looking for here is, we need to look at the two individual probabilities. A tree diagram might help with this. A tree diagram where you actually write the probabilities on there. So the first choice could happen. Event A means you get a white, right? The first one could be the first one is white or the first one is not white. Those are the two things that could happen. What are the probabilities of each of those things? So I'm going to actually write the probabilities on here. What are the probabilities there? What's the probability of A happening? The first one's white. 2/3. What's the chance of it not happening? 1/3. Okay? Now, we don't need the labels here anymore right now. If you get a white one first, and you're not putting it back, what are the chances for the second thing here? Well, actually, what if we just say, what's the chance of event B happening? What's the chance the second one you pick is white? Are you sure it's 1/2? What if you get that one first? Does it depend? Depends on what happens first, right? The chance that the first one's going to be white is 2/3, but the chance that the second one's going to be white depends on which branch you go down, right? If we think about it here, there's the chance that B is going to happen if you happen to go down this pathway, or there's the chance that B is going to happen if you happen to go down that pathway. The way you distinguish between those is you put a condition after it here. This is up here it just says chance of A happening, but this says chance of B happening given that the first one is white. What's the chance of that? So that means you have gone down this pathway here. What's the chance of B given that A has happened? So you got a white one first. This is 1/2. Absolutely, right? Now, the symbol you use for this, chance of B given that A has happened, given that, you could say chance of B given that A happened. Or with shorthand, because I know you know by now that mathematicians like to use shorthand because they don't like to write a lot of words. Chance of B given that A has happened. B, A, they don't need happened. They need a symbol for given that. What symbol do you think they use for given that? Because this is critical to realize that this is a symbol. You learned this, equal sign, that means something to you right now, right? A, this, B. If I show this to a 4 or 5-year-old, they say, what, A, 2 lines, B, I don't know what that is, right? And it takes them a while to understand what that means. This is a vertical line here. Right now you might look at it and say, I don't know what that vertical line means. And even to the end of this unit, some people think, what does this mean? B and A? Does it mean or? What does it mean? This line means given that. That line in there, this is a symbol for given that. So the chance of B given that A has happened, or after you know that A has happened. So over here I'm going to write the chance of B happening given that A has happened. What is that? What did we say that was? After this one's gone, I don't want you to think we're overcomplicating it here. After one of these is gone, what's the chance? 1 out of 2, right? Because there's 2 left. The sample space is smaller now. There's only 2 left, and one of them is white. So this is 1/2 here. Now, how can this is where this multiplication law comes from here. How can this come from these 2 numbers here? Given that the title of this is one of the outcomes is when do you multiply probabilities? Anybody have a guess? How does this number come from these 2? You divide. How do you get that number from those 2? You multiply them, right? You multiply them. You did this in grade 8, multiply probabilities, but you didn't talk about it in such a formal way with this conditional probability. I didn't leave myself a lot of space here, but hopefully you can fit it in here. The chance of A and B is going to come from the chance of A times the chance of B, except it's not just the chance of B, it's a chance of B. You have to multiply it by not just the chance of B, you have to multiply the chance of B given that A has happened. It's still what you did in grade 8 or 9. Chance of A times chance of B is when there's an AND here. But the only thing we have to look at here is make sure we're multiplying by the right chance of B here. Chance of B given that A has happened. Or if I'm going to write it over here, since I don't have lots of space, 2/3 times 1/2 gives me my 2/6 there. Okay? On this side. 2/6. Okay, that's equal to that. I really didn't give you enough space there. Incidentally, while we're at it here, what do you think what would this be down here? This probability of B here, what would we have to call that? It's down the pathway where you didn't get a white one first, so which means you must have got this one first. What's this then? Chance of B given that what's happened? That A has not happened? What would that probability be? 2 out of 2, 100%, right? Once you get the black one first, you have to get the white one second. These are different. This number is different than this number. The chance of B occurring depends on what happens first. Now, I think I'm not telling you anything new. I think you realized that already, right? The chance of the second one being white depends on what you got first. These are called dependent events, which I have sandwiched in there. You can write that down somewhere. These are called dependent events because these are different. Okay? Chance of B given that A has happened is not equal to, put a not equal to sign in between there, is not equal to the chance of B given that A doesn't happen. Those probabilities are different. If those symbols look meaningless to you, then put some words there as well, right? This says 1/2, 2/2. They're obviously not equal, right? In other words, probability of B is different or changes based on knowing that A has occurred or not. Okay, the probability of B is different based on knowing whether A has occurred or not.